Okay, how do you solve SAT right triangles problems? I honestly think this might be one of the best SAT right triangles videos on YouTube because I'm going over everything you need to know in this video. Literally every single major formula, every single concept, every single technique going to be covered in this video for right triangles on the SAT. And this is pretty important because this is by far the most common thing you're going to see in geometry problems on the SAT. Right triangles are everywhere on the test, and if you do not know how to solve these questions, you are just absolutely cooked. Now, first of all, what is a right triangle in the first place? Well, triangle, if you do not know, if you're really new to this stuff, is a shape that has three sides to it. So this would be a triangle. Right, though, means that there is a right angle within the triangle. What a right angle is a 90-degree angle. And if you don't know what an angle is in the first place, well, okay, you're probably really new to this then, but it's basically this. It would be the space between two lines that are at a, well, I don't want to use the word again, but that are at an angle to each other. So this here would be an angle. When that angle is equal to 90 degrees like this, that would be a right angle. A right angle also always appears perpendicular, so it has like an L shape to it, one right upright, the other line is immediately to the east, essentially. So that's what a right triangle is. It's going to be a triangle that looks kind of like this because it has three sides and also it has a right angle over here. It cannot have more than one right angle, otherwise it is not a triangle anymore. Okay. So there are four main things you need to know involving what you can do with right triangles when you see it on the SAT. What I really want you to do is whenever you see a right triangle on the test, just think to yourself which one of these rules could work. Because it's almost always going to be one of these four things, and it's just up to you to figure out which one will apply to the scenario, though it sometimes can be more than one as well. Okay, first thing here, this is the most common Pythagorean theorem. This happens all the time, and the reason why it's so common is because all you need to use this is side lengths of the triangle. It does not matter at all the angle measurements, though it can only be used on right triangles themselves. Okay, what the Pythagorean theorem is basically if this side is A, and this side is B, and then this side is C, A squared plus B squared must be equal to C squared. That is literally it. The lengths must add up together in this formula. A and B, it doesn't even matter where they are. All that matters is that they cannot be the longest side of the triangle. The longest side must be C, but for the other two, it doesn't even matter. I could just make this one A and this one B if I wanted to. I can make opposite. Doesn't even matter. Just A squared plus B squared, whatever those are, must equal C squared. Always also remember to have the squared at this as well. If there's not a square, it's going to mess everything up. It's not going to work. So the way this can be used, if you, for example, just have two of the side lengths, like if you know this is 1 and this is 2, you can just plug it into this formula. What that would look like would be this: 1 squared plus 2 squared, and then tilde, this also means equal sign, C squared. And then we see here C must equal 2.236, so that would be the length of this one. And keep in mind, it's almost always going to be the case that one of these side lengths is some weird number. So it's probably not going to be the case that 1 and 2 are, and then we have 3 as the third one. That's probably not going to be it. Usually it's a more weird situation, though there are a few cases where it can literally just be all nice numbers, like a 3, 4, 5 triangle or a 5, 12, 13 triangle, which you can both see in certain problems. Okay, let us use this real quick for a couple of things. A 15-foot ladder leans against a vertical wall so that its base is 9 feet from the wall. How high up does the top of the ladder reach in feet? So just to draw this, first of all, it is a 15-foot ladder. So basically what that means is this would be the ladder. This is the thing that's lying against this wall and this floor. So that'd be 15 feet. And then the base is 9 feet from the wall, so 9 there. And then we're trying to find what this angle measurements would be. This is not the longest side of the thing because the longest side is also always the slanted side. So this here would just be B, we can say. And so then we just write here 9 squared plus B squared would equal 15 squared. So therefore it has to be 12 for that one. So B there. This one, you may think this is an unbelievably difficult problem, but it's actually not even that hard because here's what's going on here. We have this whole rectangular crate. So it's a 3-dimensional object. I have a full video on area and volume if you want to see that on the channel as well. But it's asking us, what is D here? And D is the distance from this point down here at the bottom to this point up here at the top. So all we really need to do is use the Pythagorean theorem on this stuff. I guess we might have to use it twice, but it's still Pythagorean theorem stuff. First thing we should figure out is what would be the length from that edge of the box to this edge of the box. It's basically the diagonal of the square. Well, if you think about it, there is basically a mini Pythagorean theorem in here, because this is 16. This would also have to be 12 because both of these must be the same thing. Again, area and volume stuff. So therefore, we can just go ahead and say 16 squared plus 12 squared must be equal to something, and that it would be 20. Okay, so now we know here that this diagonal thing in the middle must be 20. We also already know the height of it must be 21 because it says it over here. So 21 there. And then we can just use the Pythagorean theorem again. We can say here this time 20 squared plus this time 21 squared must be equal to c squared. Okay, so that would be 29, and so d would be equal to 29 here. So therefore I go for B for the answer. Okay, you might have thought that that was pretty easy, but here's something a bit harder, SOHCAHTOA. So this is a very, very common thing. This happens all the time. And now we're going to bring angle measurements into the equation, literally and figuratively. So when you have SOHCAHTOA, what this is referring to is a group of functions you can perform on specifically an angle. So we have your sine, cosine, and tangent. Those are the three different functions. And the O and H and A and H and O and A refer to what size you have to use to figure this out. So let's say we have this right triangle, and let's say we have a angle at here, and let's just say theta. This is usually the variable that they use to show angle measurements when you don't know them yet. First thing here we have is sine. So you can say here sine of this angle must be equal to the opposite over the hypotenuse. What does that even mean? Well, when you have an angle measurement, the opposite side of it is the thing literally that's just facing across from it. Like if they're both looking at each other, the opposite is the one that is looking at this. So O would be this. And then hypotenuse, as I already have kind of hinted before, would basically be C in the Pythagorean theorem. It's the longest side and also usually the slanted side of the triangle. So that'd be H here. So the sine of this angle must be equal to O divided by H. So let's say we know here that this is a 30-degree angle, that this is a 3-length side, and we're just trying to find what H would be. We could write this by saying sine of 30 degrees is equal to 3, which would be the opposite, divided by H, and then make that tilde. The one thing we have to do whenever you're doing a problem like this is we have to go in here and switch to degrees mode. Desmos is going to automatically be in radians mode, and if you are in radians mode, it's going to mess up all your problems with SOHCAHTOA, so always make sure it's in degrees mode when you're doing a problem like this. Okay, so therefore we know here that the hypotenuse must be equal to 6. Okay, let's just go over the other one real quick. We have here A, that stands for adjacent. So this is the opposite, this is the hypotenuse. A would just be the one that is left. So this here would be the adjacent side. It's also basically just the one that is not the hypotenuse, but that's right next to the angle, but you can just remember it as it's the one that has no other real function besides being adjacent. So that is how it works. And so cosine of an angle would of course just be equal to the adjacent over the hypotenuse, and tangent of an angle would be equal to the opposite over the adjacent. Now, a couple of quick things here. All you need to know is how to do this exact formula. You don't need to know anything here about like doing -1. You may have seen this like inverse sign before. You don't need to do that anymore because Desmos can just literally do that for you when you write this in. So you can just put sine of 30 equals that. It will solve for you whatever this final measurement is, whatever it is. We also may be in situations where we know what the sides are, but just not the angle measurement. So we could put something like this. So now we see here that this must be a 22-degree angle if we have opposite being 3 and then hypotenuse being H. Now, one thing that I really want you to promise never to do is to ever just take the sine of the lengths themselves. So for example, if we had here opposite and hypotenuse being 3 and 8, you cannot under any circumstances do something like sine of 3 divided by 8. That is not how sine works. Sine is referring to something only on the angle measurements themselves, not the side measurements. The only thing you can do would be saying something like sine of some angle x must be equal to 3 divided by 8. That's all you can do. Never do the functions on the measurements themselves. That's just a way to lead to disaster pretty much every single time. And the last thing is, I have a lot of students who tell me that they're always thinking, okay, can I use SOHCAHTOA on this? Can I use SOHCAHTOA on this problem? Will SOHCAHTOA work here? The thing you should know about this is that you really only use SOHCAHTOA when there's both a side measurement given to you and an angle measurement. It's really the only time you even can use SOHCAHTOA. If you are just given sides, like in this problem over here, you really should not even be worrying about SOHCAHTOA because it's almost definitely not going to be the way to solve that problem. So just focus on it when you're being given sides and angles. Okay, let's get on some practice problems. So we have here this right triangle, and it has all these different things, so all the locations of them. It says let this thing be the angle between OP and the positive x-axis, so it'd be this angle. What is the value of tangent of that? Okay, so pretty simple. The tangent would be equal to the opposite over the adjacent, in case you already forgot. So opposite would be this one, and then adjacent would be this one. Okay, so opposite here, this is equal to 6 because we have 6 different boxes. So 6 divided by adjacent, which would be 10 because we have 10 different boxes. So 10, and I can just say here is equal to tangent of, let's just say x1 for that. Okay, so tangent of 30.96376. But you may have noticed here that it literally just says what is the value of tangent. So we actually did not even need to find the angle measurement. I just did that for you so you could see how it would work. All we actually need here is the 6 divided by 10th part, because that is what the tangent would be equal to, 6 divided by 10. So out of these choices, we're just going to see which one is equal to 6 divided by 10. It would just be 3 divided by 5. Yes, that is equal to 6 divided by 10. Both is equal to 0.6. So therefore, A would be the answer here. Now for this one here, right triangle PQR, where angle Q is the right angle of them. It says tangent of P is equal to 3 divided by 4. Now remember, tangent is opposite over adjacent. So if you have angle P here, opposite to that would be this, and then adjacent would be 4. Now the thing that you should know though is that this is not necessarily true. This is something I also see all the time with students when they're doing sine, cosine, tangent. They always just assume that it literally is exactly this number. But you see, that's kind of like misunderstanding what math is. This is not literally the number. This is just a ratio. So what this is really saying is that if you divide this side divided by that side, it's going to equal a multiple of 3 divided by 4. So think about this for a second. It could actually be something like 9 divided by 12, or it could be something like 15 divided by 20. All of these would equal the exact same thing as 3 divided by 4, 0.75. We just know that it equals that ratio in the end. So we don't know that these are exactly 3 and exactly 4. It could be 15 and 20. It could be 9 and 12. We just know that that is the ratio. So one way we could show this is just by putting a variable after it. So we could say 3x and then 4x. That's showing here that we don't know what x is. X could be any number under the sun, but we know that the ratio must multiply out to 3 and 4. Okay, it says here, what is the value of cosine of r? So we have r over here. Cosine would be adjacent over the hypotenuse. So which ones of these would be adjacent? That would be the 3x here, and the hypotenuse would be this side over here. I'm going to bring the Pythagorean theorem back into this to just find what h would have to be, and then use that to solve the problem. Okay, so we can see here that it would have to be 5. Keep in mind again that technically it may not be exactly 3 and 4, and it may not even be exactly 5. This is just what the ratio gets you to. So if I was to put it in here, I would just give 5x. Okay, so to solve this problem now, we know it's 3 divided by 5, and so that's going to be the ratio no matter what, so therefore A would be the answer. Okay, so now we have a problem like this. Many students, if they see a problem like this in the SAT, they'll think to themselves, oh my gosh, there's way too many words here, I'm way too confused, I don't know what's going on, let me just give up and move on to the next problem. But in actuality, when you see a problem like this, you can just write down the information, and oftentimes it makes it a lot clearer what's going on. And it may even be like a pretty simple problem, which it actually kind of is for this one. So we have a search and rescue drill with a helicopter hovering above level ground. So let's just imagine here, this is the distance from the ground to the helicopter. From a ground station, the straight line distance to the helicopter is x plus 8 meters. So from a ground station would not be directly below it. It would probably be something like here. So that would be the diagonal. So that would be equal to x plus 8. And then it says the horizontal distance from the ground station to the point on the ground directly beneath the helicopter, that would be x minus 1. And so if you've been paying attention at all to any of the stuff I've said so far, you would know this is in fact a right triangle. Okay, so it says the angle of elevation from the ground station to the helicopter is theta. So that is the thing. So angle of elevation, yeah, like that would be theta. And then the sine of theta is equal to 12 divided by 13. Now remember the rules again. We do not know that they're exactly 12 and exactly 13. We just know that that is the ratio of them. So sine opposite over hypotenuse. So we basically know here that this would have to be 12 times, let's just say y for the variable, and that this would have to be 13 times, let's just also say y for the variable. And now all we need to do is just use all the information we've learned so far and make some equations with these numbers. The first thing we probably can just do is use the Pythagorean theorem again, because we do have the angle measurements. So let me just go ahead and do that. I can say here x minus 1 squared plus 12 y squared plus x plus is equal to x plus 8 squared. Okay, so that's good, but if you've watched any of my videos before, you know this rule about how when you have a variable, you must have the same amount of equations as you have variables. So since we have two different variables here, x and y, we must have as well at least two different equations. So what we can literally just do is take this exact Pythagorean theorem, copy and paste it, and then just instead of this, we can just say 13y and have that be the square thing, because it would be the exact same measurement. X plus y is the exact same as 13y. They're the exact same number. And then what we get when we do all that is we get this monstrosity of a system of equations. I know you might think this is like some kind of alien thing, but in actuality, we have 4 different intersections here, and we just have to choose which one would be the right intersection for the answer. Now, you know the numbers can never be negative, because if it is, you can't have like negative distance between two things. So therefore, we have to go for the positive choice, so 6.625. We're looking here, what is the value of x? The x term in this would be 6.625. So therefore, we just plug in each of these and see which one works. If I try 53 divided by 8, yes, that is the exact same thing. So A must be right here. One more problem here with SOHCAHTOA. Again, I know this looks like it's going to be extremely difficult, but again, not as bad as it may seem. So what we have here, base point at O, and then top point at T. Then we have 2 of these cables. It just says what all this means. A is between that. Yeah, okay. So yeah, we don't really need to read all this because it is literally just what is written over here. I guess the only important thing that you may be confused on, this 20 would just be A to B, so nothing else there. But yeah. So we have x degrees for the angle, and it's saying what is the value of cosine of x. Okay, so this is again going to involve a system of equations. So I'm just going to choose some random variables for each of this stuff just so we can keep it straight. Let's say that this is equal to y. Let's say that this is h, and I guess that's basically it. Okay, just make some equations for this. It doesn't really matter what equations we choose. We just need some kind of equations. Okay, one equation we can do, y squared plus h squared must equal 29 squared according to the Pythagorean theorem. So we can write that. Another thing we know, 20 plus y squared plus h squared must equal 37. Okay, so we have those two, and it's just giving an error here because we have h here and we already have an x. So what I'm just going to do is I'm just going to write this into regression form. If you want to see my video on what regression form is and how to do that, you can check the other video I have on the channel about regression. But yeah, that's what I'm about to do here. We see here when we do that, y is equal to 3.2 and h is 28.82. Believe it or not, this is really everything we need to just finish out and solve this problem. So yeah, let's do that. So cosine of x would just be adjacent over hypotenuse. So adjacent would be 20 plus 3.2, and then divided by the hypotenuse, which would just be 37. So that'd be 0.627, and I would just try to see which one of these gives us that exact same value. Okay, yeah, it looks like A does, so it would just be A. If you're curious why I use 20 plus 3.2 for the adjacent, that's because SOHCAHTOA only works for right triangles. This triangle over here is just some wonky thing with some big obtuse angle over here. It is not a right triangle because it contains no right angle. So we have to use this whole big thing, which would be a right triangle because it contains a right angle here, for this problem. Okay, so let's get to some stuff that actually makes a bit more sense. We have something in math known as special right triangles. What these are quite literally right triangles that are a little bit special. They're a little bit special snowflakes. They appear in the same way every single time you see certain cues. It's kind of like McDonald's. Every time we see, golden arches, every time we see, greasy hamburgers, we know this is a McDonald's that we're going into. Because of those cues, we know that this is a McDonald's, and we always know what to expect as a result of that. Okay, so what they specifically are for the SAT is a 30-60-90 triangle and a 45-45-90 triangle. In case you ever forget what these are, they're actually on the formula sheet. So you can just go ahead and look at the top of your screen if you ever get confused or if you get how this works. For a 30-60-90 triangle, you must have a 30-degree angle, a 60-degree angle, and then that 90-degree angle I said before. And then in this example, the side across from the 30 degrees is equal to x, the side across from the 90 degrees is 2x, and the side across from the 60 degrees is x square root of 3. For 45, 45, 90, you just have two sides that are the exact same, and then a side that is that multiplied by square root of 2. And so the thing you know is whenever you see at least two characteristics, you know it is that thing. If I see here that there is something that is x square root of 3 and an x, I know that this is a 30-60-90 triangle because that's the only thing that could work. If I see that there's a 30-degree angle and a 90-degree angle, I know it's a 30-60-90 triangle. Same thing for this. If I see that there are two sides that are definitely equal to each other, I just automatically know it is 45, 45, 90. What you cannot do is just use one of these characteristics to figure it out. So if I just see, for example, that something is x square root of 3 and nothing else, I cannot just infer that it is a 30-60-90 triangle. In fact, many times it probably will not be. So I've had many students who come to me and they're like, okay, I just assumed this was 30, 60, 90 because that would make the problem easier. You cannot assume, and they're probably going to punish you for it by making it not work like that. So in a right triangle, one acute angle measures 30 degrees and the hypotenuse has length 14, which is the length of the side opposite the 30 degrees in units. So let's say this is the 30-degree one, and then the hypotenuse is 14 over here. Do we have enough information to know that this is 30, 60, 90? Yes, because it says here it's a right triangle, so we have a 30-degree angle, and this must inherently be a right angle as well. So those are two characteristics, 30 degrees and 90 degrees must be a 30, 60, 90 triangle. Okay, so then we know here everything else we need to know. The length of the side opposite the 30-degree angle. If we go back to what a 30, 60, 90 triangle looks like, the thing opposite the 30-degree angle must be x, and then the hypotenuse must be 2 multiplied by x. So what this means is that this must be 7 basically, because we have 7 here, and this would be 2 times 7, so 14. So therefore, the angle opposite would be d, 7. One more thing that you should know is that you can find bigger shapes that can divide out to be these. So if we have a square, for example, a square has all sides that are the exact same. I know it doesn't look like it for this because I'm bad at like drawing and stuff, but yes, all these sides would be the exact same. If this is x, then this would also have to be x. What you can do with a square is you can actually split it into two 45, 45, 90 triangles. Because think about it. The thing that makes it a 45, 45, 90 is if two sides are the exact same measurement. So this would be a 45, 45, 90, and then this would also be a 45, 45, 90. So just remember that can be split like that. Likewise, you can have an equilateral triangle, which I'm not covering in this video, but it's like when you have a triangle where all the sides are the exact same, kind of like a square. So this was x, and this is x, and this is x. For an equilateral triangle, you can actually split it into two 30, 60, 90 triangles. So if I cut it straight down the middle, we can see here that this angle must inherently be 30 degrees. This angle must be 60 degrees. And since this is directly from straight down, this would be a 90-degree angle. The reason why they must be 30 and 60 is because an equilateral triangle automatically has angles of 60 degrees for each individual one. So this is automatically 60 degrees, this is 30 because it's split in half, and then we have 90 degrees down here. So these are basically just two 30, 60, 90 triangles. Last major rule out of these four is the complementary angle theorem. This really does not appear that often, but what it says is that if you have sine of an angle, like sine of x, that must be equal to cosine of 90 degrees minus that angle. And we can just go ahead and even test this right here. If I said sine of, let's just say 6, 7 degrees, we can just take here cosine of 90 minus 6, 7. And yes, they equal the exact same amount for both things. So really it's that simple. For this one here, we have sine of this thing equals cosine of that thing. In the equation, the angle measures are cubed. What is the value of x? This must equal 90 minus this. Again, according to the rule I just said up here. This is equal to 90 minus 4x1 plus 10. And then we get x is equal to 11 here. So the value of x would just be 11. Okay, so the last thing I have here, many people do not include this when they talk about right triangles on the SAT, but I honestly think you should, because otherwise you're leaving out this major section of problems that could appear. Altitudes. What an altitude is when you have a right triangle, or theoretically it doesn't even have to be a right triangle, it could just be any triangle, where you have a line going from the top to the bottom in this kind of configuration, and it does make a 90-degree angle with the base of it like this does here. The big thing here is that you can also theoretically have a bisector, and a bisector is different from an altitude. What a bisector is when you have a line that goes from the top to the bottom, and it cuts these into equal angle measurements, but it doesn't necessarily make a 90-degree angle down here. So know the difference? All we were talking about here is altitudes. You won't really see that much of bisectors on the SAT. Even if you do, they won't necessarily be 90-degree angles, so it doesn't really matter for this video. But they are completely different things. It's kind of like if you search my name online, John H., if you search my last name as well, you will see me there, but you will also see somebody with the exact same first and last name as me who got into like a road rage incident in Pittsburgh, Pennsylvania, is in jail like right now. Okay, and so that is not me. Keep in mind, that is not me, guys, and I'm probably not even related to him. Okay, maybe I am, but probably not. So these are different things. They just both have the name John and the same last name as well. So just like this here, they look maybe kind of similar, but they are not actually the same thing. Okay, so this is what an altitude is. An altitude is when you have a line from the top going to the bottom and it makes a 90-degree angle down here. So you can basically use three different major formulas with them. The first one is h equals 2 times a divided by b. I don't even really think this is that important to remember, but basically what this is saying is h, altitude, that'd be h, equals 2 times the area divided by the base, which would just be the length of this thing. I say it's not too important because I don't think there's really going to be many situations at all when you get given the area and the base and you have to find the altitude based off of that. What you really need to know is these next two formulas. H equals square root of x times y, and then h is equal to length times length divided by base. Keep in mind, these can actually only work if the major triangle, like the full thing, is also a 90-degree angle like it is up here. If it was not a 90-degree angle over there, these two formulas could not work. So keep that in mind, but they almost always will be a 90-degree angle here, so it probably doesn't matter. What x and y are this piece and then that piece. And then the lengths are this piece and that piece, and then the base is just this entire thing down here. People often get this confused when I teach this to them for the first time because they think that this is L and this is L, or that this is X and this is Y. No, just remember that square root of these two things at the bottom, or length times length, so these two divided by B. That is how altitudes work. Okay, and so you can use these formulas just to figure out these problems pretty simply when you get given an altitude. Many people might think that problems like this are extremely difficult, but once you know these formulas, you start realizing, okay, this is actually like almost baby easy. Okay, so for this one here, right triangle ABC with C being the right angle, and it says here the altitude from vertex C to hypotenuse AB meets at point D. So that, and then splits into two segments, AD, which is 9, and then DB, which is 16. And it says, what is the length of CD? So remember the formula down here, square root of x times y. So we can literally just say here square root of 9 times 16. So it must be 12. That just is literally the answer. C must be the answer. So you can see here, this problem looked like it was going to be extremely difficult, but literally it was just one formula and I solved it. Last problem here for the video, in right triangle ABC with right angle of C, so something like this now. Altitude from C to AB meets it at D again. Okay, so pretty much same stuff as the last time. CD is equal to 6, so we already know that this time. And AD is 5 longer than DB, so we can say this is X and this is 5 plus X. What is the value of tangent of B? Okay, so a bunch of different things that are coming into play in this problem. But let's just use all the stuff from this video so far to figure this out. So first of all, with the altitude stuff, again, it's this formula H equals square root of X times Y. So I could just literally go here. 6 must be equal to square root of x1 multiplied by 5 plus x1. So yeah, literally that simple, so this must be 4. So therefore we know that this thing would be equal to 9, and this would just literally be exactly 4. Okay, so then how do we find the tangent of B? Tangent would be here, so we need the opposite and then the adjacent. So we need to use the Pythagorean theorem on both of these now. So first on this one, this would be 6 squared plus 9 squared equals C squared. That'd be 10.8 something, so let's just say that. And then for this one, it would just be literally 6 squared plus 4 squared equals C squared again, so that'd be 7.211. And then tangent of B would be the opposite over the adjacent, so something here like this divided by this. So 1.5, that would be also equal to 3 divided by 2, so therefore B is the answer. So hopefully you feel like, you're combining infinity stones here. You've learned all these different things, and now basically like almost every single thing up from this video comes into play on this exact problem here. And you really should pay attention to this video very closely because this stuff happens all the time on the SAT. Even when you get to the more advanced geometry problems, this stuff still happens again and again. It's something that just like keeps appearing again and again, and once you know it, it makes all these so much easier. As a reminder, check the link in the description below to see Mission 1400 Plus. A ton of great stuff in here, plus I'm currently doing a deal where I will actually review your practice test if you join even just on the free trial in the first 7 days of you joining. So you can give me your practice test and I'll record a full video explaining everything I think went wrong and everything you need to improve for your next attempt. All of it available here, plus all this other stuff you can see down here as well. I'll see you guys in there. Good luck on the SAT and make sure to always stay Gucci.